Hi there, my name is Mr. Beep-Bop, as you can see right here, and today, well, first of all, let me introduce myself and what on earth I'm doing. I've already said my name is Mr. Beep-Bop, and I'm just going to be trying to, show you all, basically, make sure that you all have an understanding of certain concepts in maths. So we'll be working through to more difficult things like algebra and things like that. But before we get there, we first need to look at some quite basic concepts. And this is like a main one really, and it's why do we need to add? Why do we need to add? Because really, why? If you start thinking about it, it's quite a perplexing question. And it all really goes back to the same kind of idea of why on earth do we even need numbers themselves? So let's just have a look at that question first. And as you can tell from this absolutely amazing sketch of mine here, and I shouldn't, oops, this is clearly an apple. So let's do this here. I'm going to copy and paste it, and I'm just going to have, I think, how many apples are we going to have? We're just going to go up till I feel like it, I think. I think we'll do one more. There we go. Now, if I asked you, how many apples do we have here? Most of you, I would assume, would say 5. We have 5 apples here. But why do we even say 5? Well, let's start off here and just count using our number system. So 1, 2, 3, 4, and 5. So here we go, 1, 2, 3, 4, 5. And because, let's say this list of numbers here ends here, so does this one here. So it starts here, so this starts here, and ends here, so it ends here. Okay, and we just take whatever the last number is. So in this case, it's 5. As we can see here. So we have 5, and we can say that it's 5, but let's just forget about our number system for a moment, and let's go back to the very foundation of counting itself. So let's count this in quite a different way, really. And we're going to say, right, here I have 1 apple. 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 And here, you guessed it, I have 1 apple. So let's write this number now. 1, 2, 3, 4, 5, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. There we go. Here is a perfect representation of how many apples I have. But if you just look at this number, it can get quite confusing. It's almost like, it's just quicker really than just drawing a picture of an apple. That's all we really use this for. But to most people, this just looks really weird. Now, some of you may have noticed that actually what we can do is just take away this one here and redraw it on a diagonal. Now, it looks a lot more familiar, I would imagine, to some of you, because this now looks a lot like a tally chart. Now, what is a tally chart? And a tally chart is basically a very basic thing that was developed possibly thousands of years ago that was just used for counting and representing how many of something that you had, much like we're doing with these apples here. So here, if I just draw a representation of 15 using this tally chart, here is my 15. Okay, so this is basically how it works, but why do we need a tally chart? Well, it's basically just so if someone comes over to you and says, "Ooh, can you give me something that shows me how many apples you have?" So let's say you have 15 apples, and instead of you just giving them the 15 apples, it's a lot easier maybe just to give them a piece of paper with this on it, and it perfectly represents the 15 apples, and it's just a lot quicker to do. So it's just really a quicker way of putting across that understanding of what is essentially the same thing. So let's go back to this idea of our number system and why it's slightly different, because we've developed this number system here with these kind of digits, and our number system is called denary, but the numbers, the digits that we actually use are called Arabic numerals. So here are the Arabic numerals. Now a lot of people don't know that these are called Arabic numerals because most people just see them as numbers, but this is what they are. Now, most people, I imagine, will have heard the term numerals somewhere else, and it's used in the term of Roman numerals. So let's say these are the digits of our Arabic numerals, and we're just going to label them AN. Okay, now let's look at our Roman numerals, and let's have a bit of a comparison. So we have I standing for 1, V standing for 5, X for 10, L for 50, C for 100, D for 500, and M for 1000. And these ones are used over and over again to represent any number, as are our Arabic numerals here. Now you can see, first of all, this actually seems that, is it a little more efficient then? Well, it all comes down to, if we just use ones, is this more efficient than just using our number system? Of course not. So just like this, it does become quite complicated. So let's just represent a very simple number. We'll represent our digit 6. So we'll represent it in both Arabic numerals and Roman numerals. So here is our number 6. We'll just write 6 as a little subheading here, so we know what we're representing. Okay, 6. This is definitely an I, by the way, or it's supposed to be. So here's 6 in Arabic numerals. Quite easy to understand. Here is 6 in Roman numerals. Oh, now here we have to do a little bit of extra work, because actually what we're doing here is we're saying 5 and 1. And this comes back to our main question of why do we need to add? And the reason we need to add is to get to this value of 6, because 5 plus 1 equals 6, and that is why we need to represent it like this. But why do we must have been adding before the Romans, surely. They can't just come along and say, we're going to found this great city, and we're going to found addition at the same time. And you're quite right. And we actually have already done a little bit of simplifying with the numbers that we've had, because we're not just writing 1, 1, 1, 1, 1, 1, 1 over here. Like, for example, just let me show you what I mean. We're not just writing it like this, and so on and so on. We're writing it like this. Now you can see here that these are quite clearly separated into groups of 5, and this just makes it a lot easier to write. So this looks a lot like our 5 times table. So basically it's 5 plus 5 plus 5. Okay, here we go. 5 plus 5 plus 5. And that is how we make the 15 up here. So we see the basic kind of thing, but why can't we just say add 1? Just count up in our number system, and there we have it. Well, it goes a lot deeper than that, really. So let's just have a quick look at another little bit of concept here. So we'll just get rid of this, and we'll go back on this. So we'll go back to kind of like a similar example. So 8 plus 9 equals 17. Now, first of all, these numbers are quite close to each other, which means it's quite difficult. Because if I say 1 plus 60, it's quite easy, because we just count up 1 from 60. You see what I mean? Okay. It's quite easy to decide which one just to count up with. Alternatively, I could say, right, so we have 35 and 6, and we can tell it's a lot easier to count 6 onwards from 35 than 35 onwards from 6, so that would be 41. But here, they're quite close to each other, they're only within 1, so it's going to take us a similar length of time to add on however many. So let's say adding on 8 from 9 and adding on 9 from 8 is going to take us a similar amount of time just to get to this number here. Which means that although adding 1 does get the correct answer, it's just a lot easier if we can just add in general. And that is why, in essence, we need to add. So, that's it. Basically, that's the basic construct. We're going to have 4 of these basic construct kind of videos. We're going to go into addition, subtraction, multiplication, and division. So if you haven't already looked at those, maybe check those out if they're on my channel already. So let's just, yeah, without any further ado, that's goodbye from me. Watch the next video. This has been me, Mr. Beep-Bop, signing off. Bye-bye.